Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well today and you are ready for today's program. Today on the show, we have a very, very fun one for you because Ralph has put it together. He has done everything, and we always really appreciate that our science and technology trends correspondent comes in and saves the day with some uplifting news, because if you have been paying attention to the news, I worry for you, but also, hey, you need something a little bit more uplifting, and don't worry, we have that for you. So we have 4 different stories, and they're all going to be in the vein of science and technology, and odds are you probably haven't heard of these. So it's going to be a lot of fun. Everyone, computeramerica.com. That's where we'll find everything, including past shows, future shows, show notes, articles, really any podcasts, anything that we do here on the program, you can find at our website. Go check that out. And while you're there, the show notes are of supreme importance for today's program, because if you're driving, if you're busy, or if you just want to follow along, by the time that you hear this, the show notes will be up, and you can, of course, read along and investigate a little further. So with that being said, let's go ahead and just bring Ralph on and have fun with it. You know, it's a good Friday. It's not the Good Friday. It's a Good Friday. Ladies and gentlemen, let's go ahead and bring Ralph on. Ralph, welcome back onto the program. How you been?
I've been doing great. Just finished a big trip throughout the Northwest Midwest, Midwest, Michigan, Chicago, Illinois, Indiana, and all that good stuff. And as you and I were chatting before the show, I have never seen so much corn. I've never seen so much corn and so much soy in my entire life on flat, endless miles and miles of farm fields. But what beautiful country and great people.
Absolutely. No, it really is a beautiful part of the country. And I know that, it has the not so affectionate name Flyover States, but no, it's it's all really beautiful country and worth at least once in your life going out there and checking it out.
Absolutely.
So how'd you get around, by the way? Did you drive? Like, did you clock how many miles you did over the course?
Drove in many cases close to 300 miles of driving every day.
Wow. That's
but it was fun. It was really interesting.
Well, I'm glad you had fun. And now you are back, and you have you have made the show notes, and you have brought with you a number of stories. So let's tell the nice folks out there, after your long journey, for anyone out there who may be new, what it is that you exactly do here on our segment.
That's right. Every Friday, folks, if you're new to the show, welcome. Great to have you. And what Ben and I do each Friday is highlight 4 recent articles that show us key trends and developments in artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agri-tech, space research, physics, you name it, all across the board. But most important of all, as we alluded to a moment ago, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And story number 1, it sounds like could be the title of School Children in South Florida. Soda cans, seawater, and caffeine. But no, it's going to be a little bit different. So Ralph, let's start with that.
This is an irresistible story and actually very, very interesting. It comes from the MIT, that's of course Massachusetts Institute of Technology newsroom, and the headline, how could you resist this? A recipe for zero emissions fuel, soda cans, seawater, and caffeine? What? Well, irresistible, and I think you're going to enjoy this a lot. So let's get into the story here. MIT engineers have found that when aluminum in soda cans is exposed in its pure form and mixed with seawater, the solution bubbles up and naturally produces hydrogen. What? Wait a minute. Aluminum in its pure form mixed with seawater, the solution bubbles up and naturally produces hydrogen, which of course we know is a gas that can be subsequently used to power an engine or hydrogen fuel cell without generating carbon emissions. What's more, this simple reaction can be sped up, accelerated by adding a common stimulant, caffeine. This is so wild. I just love it. And in the show notes, by the way, Ben mentioned the show notes at computeramerica.com for today's show will have links, have the text of our notes here, have additional information in the category of additional information. If you're not familiar with what a fuel cell is, I inserted a little tutorial on fuel cells that I picked up from my Copilot online AI search. So that you can check that out. We won't go through that here on the show right now, but let's get back into the story. In a study recently appearing in the journal Cell Reports Physical Science, the researchers show that they can produce hydrogen gas by dropping pre-treated pebble-size aluminum pellets into a beaker of filtered water. And in fact, there's a video on YouTube showing exactly what they're doing. And the aluminum is pre-treated with a rare metal alloy that effectively scrubs aluminum into a pure form that can react with the seawater to generate hydrogen. The salt ions, and by the way, you might be thinking at first, everything sounds great. Now you're saying rare metal alloy. Uh-oh, that means it's going to be an expensive process, a problem. Wait a minute, check this out. The salt ions in the seawater can, in turn, attract and recover the rare metal alloy, which can be reused to generate more hydrogen in a sustainable cycle. Wow.
If I had paid more attention in science class, I could give you the name of a catalyst that is not consumed in the process. But yeah. So.
Yeah. It's basically that kind of concept. Isn't that great? And so in the show notes, if you want to find out what is this rare metal alloy, it happens to be eutectic gallium indium. I hope I'm saying that right. Shortened to E-gallon. Itself is not a single metal, but an alloy of gallium and indium. That's what they used. And in the article, they didn't give this explanation. But again, in the show notes, I've got optional information for you to come and learn about this rare metal alloy they use. But how fascinating that it can be retrieved. And it becomes this endless cycle over and over again. And in the show notes from their research paper, I have an illustration showing the whole sequence of the process of how this works. Just amazing. So the team found that this reaction between aluminum and seawater successfully produces hydrogen gas, but very slowly. So keep that in mind. On a lark. What made them think of this?
As
on a
all
lark.
Scientists do on a lark. Yes, of course.
Yeah. Well, I think the thing that always amazes me, Ben, and you too, I'm sure, is where do they come up with this stuff? How did they think, I know, let's see what happens if we toss into the mix some coffee grounds, and found to their surprise that the reaction picked up its pace, quite a bit, in fact. In the end, the team discovered that a low concentration of imidazole, imidazole. Help me out on Friday morning. An active ingredient in caffeine is enough to significantly speed up the reaction, producing the same amount of hydrogen in just 5 minutes that before they used the caffeine took 2 hours without the added stimulant. So in 5 minutes, they got the results that prior to adding the coffee grounds took 2 hours.
I mean, the low-hanging joke there is, of course, just like humans. A little bit of coffee, you can get something done in minutes that would have taken you hours.
Yes, amen to that. As exactly. I take a sip of coffee,
and I love the fact that MIT of all places says on a lark they decided to. So I'm sure it's a bit more clinical than that, but still very fun anecdote from this.
I'm sure there's an amazing backstory there to how did they figure out that the ingredient, that the stimulant in coffee could do this. It's just fun. I'm sure there's a deeper story there.
Yeah.
But anyway, the researchers are developing a small reactor that could run on a marine vessel or underwater vehicle. The vessel would hold a supply of aluminum pellets recycled from old soda cans and other aluminum products. Love it. Along with a small amount of the gallium indium and caffeine. So that alloy and caffeine. And these ingredients could periodically be funneled into the reactor along with some of the surrounding seawater to produce hydrogen on demand. What? Hydrogen on demand. The hydrogen could then can then fuel an outboard engine to drive a motor to generate electricity to power a vessel or ship. Just let all this sink in. This is just what? Anyway, as one of the key researchers noted, we're showing a new way to produce hydrogen fuel without carrying hydrogen, but carrying aluminum pellets, in this case, as the fuel. The next part is to figure out how to use this for trucks, trains, and maybe even airplanes. Perhaps instead of having to carry water as well, we could extract water from the ambient humidity to produce hydrogen. And the researcher says, of course, that's all down the line. So that's the big future vision for this. But what an incredible discovery and innovation.
Yeah, and the video really showed just how, kind of quickly this whole reaction kind of takes place, and you start getting this weird aluminum slurry that's bubbling and, looks very disgusting. But at the same time, they already went through, kind of what it all is. But no, I could totally imagine that, having to carry, a solid instead of a liquid, like liquid gas or diesel or something like that, and you could just carry little pellets of aluminum. Obviously, Ralph, like you like to say, twinkle in the eye. It is way down the line.
That's right.
But it is all real research. This is they have found these in a lab. So the next is to test it in the real world and get it moving down. So very cool though. Very, very cool. So story number 1, there you go. Story number 2, we're going to go ahead and jump on over. And story number 2 is going to be, once again, hydrogen, if you're seeing a theme here. And though this is something a little bit closer to maybe not your home, but maybe one day someone else's home. So story number 2.
Yes, story number 2 comes from an outfit called The Cool Down, which is a fun resource. Headline, City Unveils World's First, and here we are with hydrogen again, World's First Hydrogen Apartment Block. Here's how this technology could revolutionize the future of housing. Again, from the outlet called The Cool Down. Yeah, this is an example of a trend, I would say. Not so much early research and maybe someday. No, this is happening. So, but it's a trend. Are we going to see more of this in the future? Maybe yes, maybe no. But here we go. Urban living in Ulsan, Ulsan, South Korea, just got an eco-friendly upgrade thanks to the world's first hydrogen apartment complex, which was recently unveiled in the, and God forgive me, anyone who's Korean, BUK-GU, Bukgu district. I'm sorry.
Yes, something like that. District. Yeah.
I'm sure I'm butchering it. So called the Yuldong with You apartments, all 437 units are powered completely by hydrogen fuel cells, which can not only lower the residents' electric bills by 30 to 40%, but also have a positive impact on the planet, according to the online news article published in another outlet called fuelcellsworks.com, which is also interesting. And this article embedded information from many other articles as well. So here we go. According to another article on this project in Interesting Engineering, the apartment complex is powered by the Yuldong Combined Heat and Power Plant, which is located only 200 meters away from the complex. So what you're going to see in this story is a synergy between this power plant and this apartment complex, and we'll explain as we go on. So the plant used hydrogen as a byproduct and received it via a 10-kilometer pipeline from nearby industries. And 10 kilometers, by the way, is approximately 6.2 miles. Using hydrogen, the plant generated heat and power with reduced environmental impact. So that's the power plant. So put that on one side of the equation. Since the power plant first came online in June of this year, it has generated around 840 megawatts of energy valued at about 150 million won, their currency, which would be about $109,000 US. That means hydrogen could be a game changer when it comes to powering big cities with clean, abundant energy. So that's the power plant part of the story. Here we go to make the connection. 3 container-sized fuel cells on the apartment complex's roof, which hold the hydrogen supplied by the power plant, produce up to 1.32 megawatts of electricity from around 112 pounds of hydrogen per hour. And when the article says container, Ben, my guess is they're talking about shipping container-sized boxes. Again, they don't specify; they just say containers. That's my guess.
So, and now we're just making the website all wonky. Yeah, the actual website, the Fuel Cell Works, they have the mock-up of the apartments there, and you can see these giant boxes with some wiring and some stuff here. So, they're bigger than an AC unit, and I'm sure that these are actually elevators. I'm, just misinterpreting this, but
hard to say.
But especially for being on the roof, you're probably not even going to see them. So it's not like it's going to be a big ugly thing that is going to impact everyone. No, it's probably just something on the roof.
Yeah. And then going back, excuse me, to the coverage in Interesting Engineering, they explained that this is enough energy created to provide a month's worth of power to 4 average-sized households each hour. Wow. In addition, I love this part. In addition, heat generated in the process is captured and stored in a 40-ton energy-efficient thermal water storage tank. In turn, that water, which can reach up to 70 degrees Celsius or 158 degrees Fahrenheit, is then piped into the apartment units for heating, making the entire process planet-friendly. Wow. Okay. So again, friends, this is something that's happened in South Korea, and it might be an indication of where we're going as other people around the world look at this solution and say, hey, we can do this too. Of course, in their case, they did have this power plant close by. Yeah. The power plant had as a byproduct hydrogen. They could get it to the fuel tanks at the apartment complex. So not everywhere and everywhere in the world are you going to have that scenario.
And of course, you're now living super close to a power plant, but at the same time, that's probably very good for hydrogen fuel, which, Ralph, we talked about. Piping at places and delivering at places is really one of the hardest parts of hydrogen, is that it's so small, it tends to escape. So being close is helpful, and Ralph, they've really considered a lot of parts of this by piping the excess heat throughout the building and doing this, that. It's as environmentally sound as you can. And, hey, it doesn't sound like a lot, but that's 4 apartments where people can now live and, live in a much more eco-friendly and cost-effective way. That's the trend that I hope continues, is just innovative, creative ways to use what we're already doing more efficiently. That's always very, very helpful. So.
Yeah, very much. And the other thing that I find interesting about this project is there's no reference to solar energy as part of the equation. It's all a completely hydrogen-based solution. So that's kind of interesting as well.
Yeah, no, the other solutions will definitely play a part, but I guess, the power plant being the power plant, they're focusing on things that, kind of convert the hydrogen. Either way, that's story number 2. Story number 3. And this one, when I was reading it, I was like, all right, the joke I'm going to tell everyone is, yes, Inspector, there's mold in my wall. No, it's okay. I put it there. Story number 3 is very, very strange. And it looks so cool. So highly encourage you to come check out the pictures. I don't know if ladies and gentlemen, it looks like, no offense to the authors or, the researchers, it looks like baby green vomit, shag carpeting, but, I'm sure it has much more eco-friendly properties, and I don't mean to be disparaging. This is actually a very, very cool story. Ralph, let's go ahead and get into it before I completely turn everyone off the idea.
Well, actually, you raised a good point. Friends, if you're listening to us as a podcast, please come out to computeramerica.com. Get the show notes so you can see these images and go out to the articles and see even more images and so forth of what we're talking about, because it is curious looking stuff. But here we go. Let's explain. This story comes from techexplore.com. Headline: New living building material draws carbon out of the atmosphere. And again, from techexplore.com. So a new construction biomaterial, that's important, biomaterial that uses living microorganisms, to extract carbon dioxide from the atmosphere has been developed by a University College London graduate student and colleagues. The biomaterial developed by a master's student in the University College London Bio-Integrated Design Program. Imagine that. They have a program called Bio-Integrated Design Program, could dramatically reduce the construction industry's carbon footprint if mass-produced and widely adopted. However, the aesthetics of this, as Ben was alluding to, could be challenging because it is kind of weird looking.
Yeah, it's yeah, ladies and gentlemen, come check out the picture. It's kind of like a dried, like, pool algae, just on the surface.
Yeah.
I don't know. It's very unique. Like, it's not bad looking. Like, honestly, it's very natural. So it kind of invokes, the feeling of like a forest or something like that. But
Yeah.
it is not like concrete or wood like you expect from construction. So
That's right. And again, we're talking about wall surfaces of this material.
Yeah.
So we did if you're a podcast person, you need to understand that as well. So it was unveiled as part of an art installation.
yeah, that makes sense.
Isn't that cool? In St. Andrew's Botanic Garden in Scotland, and incorporates living cyanobacteria into translucent panels. That's key. Translucent panels that can be mounted on the interior wall of buildings. Wow. As the microorganisms embedded within these panels grow using photosynthesis, they pull carbon dioxide out of the air. And through a biomineralization process, and I have a link there to learn more about that in the show notes, through this process, affix it to calcium. In other words, the carbon dioxide, they affix it to calcium to create calcium carbonate, locking away the carbon. So it's absorbing the carbon from the air and then trapping it. Wow. A kilogram of this biomaterial, known as cyanobacterial engineered living material, can capture and sequester up to 350 grams of carbon dioxide. Now, here's an interesting thing. While the same amount of traditional concrete, if that wall were made out of concrete, will emit as much as 500 grams of carbon dioxide, will emit. So not only is this trapping the carbon dioxide and absorbing it, as compared to concrete, tremendously much more efficient, as opposed to, the concrete's putting out carbon dioxide. This is sucking it in and trapping it. So that's the key thing to keep in mind.
I sadly did not know that. And like, I knew that it kind of went into the process with water and everything like that.
Right.
But I did not know that over the course of its life, it would, kind of emit that CO2 back out. I thought it was locked away once it was concrete. And a quick Google search says that between 4 and 8% of global CO2 emissions come from concrete. So I'm sure that's through the production and use, and then, of course, the off-gassing of it. That is interesting. I had no idea.
No, you're right. And then that was a bit of a surprise for me, too. I knew about in the process of making concrete and installing concrete and so on and so forth, but I didn't realize that once it's all dry and done and sitting there, it's in some measure emitting carbon dioxide. That was a surprise for me as well. Yeah, but going back to the article here, a 150 square meter wall, that's approximately 1,614.59 square feet, covered with these cyanobacterial engineered living material panels, will lock away approximately 1 ton of carbon dioxide. That's pretty cool. The panels themselves are designed to offer a range of cosmetic and structural benefits for buildings. They are lightweight, sound absorbing, translucent enough to transmit light through, and thermally insulating to enhance the energy efficiency of buildings. Well, that's a lineup of benefits: lightweight, sound absorbing, translucent enough to transmit light through, and thermally insulating to enhance the energy efficiency of buildings. So early research, it is quirky. It is kind of curious looking. It probably wouldn't fly for most people. I don't think my wife would want these on the walls of our house, but in, say, civic installations, public spaces, it could be not
It's
only cool but very effective.
I mean, it does have a kind of a funky design to it, and funky look. It is a biomaterial, so it's going to look, like algae and kind of stuff like
Yes.
that. But at the same time,
Palms.
Ralph, I really enjoy that. First of all, the whole program. I enjoy the London Bio Integrated Design Program.
Gotta love
So it's obviously trying to incorporate living things into construction, but
Yes.
it's like this is pretty low effort. Like once you've hung it, it just kind of sits there and does its job, and then it solidifies, and it is what it is after that. Ralph. Like
Yeah.
there's not a lot of activeness that needs to happen after you've installed it. So there is a lot to like about this. There really is.
And one thought comes to mind, Ben, and maybe it's occurring to you as well. We've had years and years and years of people experimenting with bio roofs. So with planting and putting biomaterials on roofs for insulation purposes and carbon dioxide capture and all that good stuff. Here we're talking about taking that concept in a very different way, but putting it inside the building as part of wall treatments. I thought that was really cool.
It's I hope that they find real application for this, and they find a way to kind of produce this, because again, it's not the worst looking thing in the world. It could have application. Now, some of the numbers that they're throwing out in the article, if you just install a 2,000 square foot panel of it, if you just use it all over the planet, if you just replace concrete with this, not exactly what they're kind of saying in the article, but still, it's very, very cool. So, story number 3, if you want to find out more about that, you can go check that out. Links in the show notes. Story number 4, let's go ahead and move on to our last one. And Ralph, as always, you like to do medical news on our 4th story, and you certainly did. This will be for everyone out there who, over the years, you go to kneel down and you're like, oh, that hurts a whole lot. Hope for you with story number 4. So let's go ahead.
Yes. And this is a great example of not only medical technology news, but ending the show with very promising, very uplifting news. This comes from Northwestern University Engineering News, their website, of course. Headline: New biomaterial. Talk about biomaterials again. Here we go. New biomaterial regrows damaged cartilage in joints. And if you're familiar with the whole world of cartilage, that's like, wait a minute, what do you mean regrow damaged cartilage in joints? That doesn't happen in nature. Well, stand by. This is a great, great breakthrough. So Northwestern University engineering scientists in Evanston, Illinois, have developed a new bioactive material that successfully regenerated high-quality cartilage, in the knee joints of a large animal model. In the article, I couldn't find what animal they're talking about. Maybe it was a pig. I'm not sure.
I would guess large animal would be something that's fairly accessible, which I would imagine like cow, if I had to guess.
Cow or pig, maybe.
Yeah, cow or pig,
sure.
or just something a bit heavier.
Yeah.
I assume.
And then it goes on to say, although it looks like a rubbery goo, the material is actually a complex network of molecular components which work together to mimic cartilage's natural environment in the body. This is some amazing research. In the new study, the researchers applied the material to damaged cartilage in an animal's knee joints. And again, the article doesn't identify what kind of animal. But in a way, who cares? This is so great. Within 6 months, the researchers observed evidence of enhanced repair, including the growth of new cartilage containing the natural biopolymers, collagen 2, and proteoglycans, which enable pain-free mechanical resilience in joints. Wow. With more work, the researchers say the new material someday could potentially be used to prevent full knee replacement surgeries, treat degenerative diseases like osteoarthritis, and repair sports-related injuries like ACL tears. Wow. If that's just that one paragraph just blows me away.
Yeah,
Can
no,
you imagine the implications?
Yeah, my mom went through a car accident and she got like, a bunch of blown discs throughout her neck. The cartilage is completely gone.
Yep.
And she keeps up on a lot of the research that goes into like Tiger Woods. He had his,
Oh, yes, right. Right.
the cartilage in his neck, and if it affected his sports career.
Yeah.
Ralph, like athletes all over the world are looking for the thing that's going to regenerate their cartilage so that they can get back to playing sports and doing what they used to do when they were younger. Or even just pre-injury, not even age, it's just pre-injury. And right now, the solutions are not good. So any research in this field, like I'm sure every pro athlete is like, I need that because this is what lets them do their job.
Yeah, yeah. And to conclude, and really this strongly stresses the unbelievable importance of this research. So Northwestern University's Samuel Stupp, S-T-U-P-P, who led the study, said, quote, "Our new therapy can induce repair in a tissue that does not naturally regenerate. We think our treatment could help address a serious unmet clinical need." All I can do is stand up, picture me standing up, applauding. Hooray for all of you guys. This is so important and so great.
Standing up for those who don't have the cartilage to do it themselves. Absolutely. It's definitely good.
Yes,
No, and by the way, just skimming, ladies and gentlemen, I want to again throw appreciation to Ralph. Just skimming the article to see what kind of animal they're trying to test on. I did find it, but I got to say, holy cow, or I should say holy sheep. That is a heady article. So thank you for breaking that down for us and getting us the relevant points. Yes, it was the researchers tested it in sheep with cartilage defects in the stifle joint. So I don't know where the stifle joint is, but there you go. So it was in sheep.
Okay, thank you. That helps. That's very cool.
So with that being said, and that's the value I do. I identify sheep. That's all Ben does. But with that being said, that's story number 4. Ladies and gentlemen, if you want to find out more, computeramerica.com. And if you are following along in the show notes as we kind of go along, then you may notice, hey, Ben, there's more. That's okay. That's for you. The honorable mentions are, as we like to say, not worse, not less important or less uplifting. It's just, Ralph, we try to keep it to a certain time because we know that your time is precious. So, hey, we're going to try to do that. So if you follow along in the show notes, there's more. And ladies and gentlemen, computeramerica.com, come on out and you can find these at the bottom of the show notes. So, Ralph, let's at least give the nice folks the headlines of said honorable mentions.
Right. We've got 4 honorable mentions this week. First one comes from Anthropocene magazine. Headline: Engineering plants with deeper roots could be a huge climate boon. Scientists just made a big find. This all has related to climate change and so forth, and having to design plants that can better deal with this new, drier, hotter world we live in. And then the next one comes from Interesting Engineering. World's first, this is really interesting, world's first AI-powered hearing aids boost speech understanding by 53 times. Wow.
That's a huge improvement.
When you talk to an audiologist, for example, I'm tested for my hearing and I can hear the sounds. They do the beeps and all that sort of stuff. But when my wife talks to me, I sometimes go, say that again. It's understanding the speech, not just hearing the sounds. Yeah. And so this really addresses that need, and I salute this article and this research. Next one comes from techexplore.com. A new tool from the U.S. Department of Energy's Argonne National Library simulates real-world vehicle traffic to predict large-scale energy impact. There's a lot going on in this article. I encourage you to check that out, but it's a great example of using research to figure out how traffic patterns work and how we can make things more efficient to save energy. And then the last one of the honorable mentions this week comes from phys, phys.org, short for physics.org. Engineered microbes found to repel mosquitoes. And this time of year, that's a really important topic for many of us around this country, is darned old mosquitoes. And check this out. They figured out a way to make a repellent. Very cool stuff.
Very, very cool. And yeah, mosquitoes have gotten to be such a such a pervasive problem. And the old way was just tons of pesticide. But hey, ladies and gentlemen, we're getting to do something better. And maybe just repel them all together. So, ladies and gentlemen, that's the show for today. That is 4 great stories, 4 great honorable mentions, and Ralph, a partridge in a pear tree. Thank you so much for coming on the program and discussing these with us. Ladies and gentlemen, if you want to find out more, computeramerica.com, as we've been saying the whole time. Check out the show notes. And everyone, Ralph's on every Friday. If you want to check that out, hey, check back next week. And until then, have a great week. Do something fun this weekend. Bye, everyone.